I'm gonna talk about the story of Mark, one guy. He's 30. He lives in Toronto, and he likes computers and math. So he just bought a new computer, and he also bought a new vintage monitor. Uh, so let's give a look at what he's trying to do. So in his free time, when he's done with work, he thinks about projects to 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 spend time and work on his hobbies. So one of them um, is a project where he wants to detect whether a picture is a ball or a stick. So I was mentioning that he just bought a new monitor, vintage monitors. So this is an old kind of screen where there are only so many pixels. So you cannot make, you cannot use them to display HD pictures. But in this case, a pole is basically 1 point. So only one pixel is on, and one stick is basically three pixels in a row that are activated. So for example, this is a ball, and these are two examples of sticks. So what he is trying to do in his new project is trying to figure out, trying to write a computer program that is able to distinguish whether something is a picture is representing a ball or a stick. And it looks quite simple. Maybe some of you have some ideas of how can this be done. Could you guess how we will implement this? Sorry? It's even more simple than that. So he finds a rule that is able to distinguish a picture of a stick and a picture of a ball. So before talking about it, maybe we have to have a common understanding of what is a digital image. So in this case, the image can be represented as a list of zeros and ones. So, for example, in the first picture, every pixel is zero because it's off. So we can say that it's a list 0, 0, 0, and so on until we get a 1, and then so on, it's 0 until the end. So if this is a screen that is 8 by 8, there will be 64 pixels, and the first 18 are 0, then there is a 1, and then the rest are 0. Does it make sense? Okay. Then we can look at the other two pictures. This is the same, so it will be 0, 0, 0, then 1, 1, 1, and then 0, 0, 0 till the end. So it's like a list of numbers, and each number could be either 0 or 1. If it's 1, it means that the pixel is black. If it's 0, the pixel is white. And we can use this encoding digital representation of a picture to represent a given number of objects. Of course, this is a very low definition, so maybe we cannot represent beautiful pictures, but we could still use this monitor to show some basic objects. So an idea of how he could do, like, he has this digital input of, I don't know, 64 values, and he has to decide, find some rules to decide whether this list of values correspond to a ball or a stick. So how can he go on to solve this problem? Any idea?
Put it in a matrix and you see. I think you want to loop on it and check if it's consistent. It's probably a stick. If it's not, it stops at 2 or less than 2. Then it's a ball.
Yeah, that's right.
What? What's that?
So basically what he said is that he can implement a loop, which is basically an algorithm that is able to check one by one, iterate through each of these 64 values, and check whether, for example, it's black, it's 0 or 1. So for example, if he goes through all these 64 values one by one, first checks the first one, then the second one, then the third one, and he finds that there is a single dot, black dot, then it means that that picture is a ball, right? While if he does the same, he goes through all the values in the list, and he finds that at some point there are 3 consecutive ones, then it means that it's a stick. Does it make sense? So this is quite a simple program if you know how to code, how to use do software development. Maybe you can use less than 10 lines to implement this algorithm. So it's quite easy. So Mark manages to solve this problem. But now he's bored again, so he wants to find a new challenge. So this time he wants to identify handwritten digits. So he has the same monitor again. I don't know if it's 8 or how many pixels for each side, but he wants to write a program that is able to identify which digit does this correspond to. So it could be any digit between 0 and 9, and any idea of which approach can he take?
It's to have ground truth.
Sorry, what?
Can you have like a kind of a reference of how it is?
Yeah, he can, for instance, yeah, he knows how the chew looks like. So more or less based on that, he could.
So he have to give like 1 to 9 all the handwritten, what is it called? Whatever the
Handwritten digit, yeah.
as an input.
Right.
So they can recognize.
Yeah. Yeah, that's a good idea. Yeah. So basically, what he does. So the first approach would be to do something like before. So there are, I don't know, this is for 8 again, yes. So there are 64 values on the list. So this is going to be 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, and so on until 0, right? So you go 1, 1, 1 till the end. So he says, well, if there is this specific arrangement of zeros and ones in my list, then it's going to be a true, because I mean he can recognize this to be a true, right? So, but then there is a problem. What if I represent the true like this? So there could be potentially infinite, maybe not infinite, but many ways to represent a true in a digital image, right? Um, so how can he go about qualifying all these possible combinations of true? It could be something like this as well. And yeah, so this becomes a problem. So either he tries to find all the possible representation of a true, and then he does the same for all of the 10 digits, or he has to find, otherwise he has to find another solution. So he goes on, nights sleepless, cannot find a solution, and he's about to give up. But someday after a month, he gets struck by an idea and tries to implement it. So what's his idea? His idea is to gather try drawing many digits. So for example, he starts with 0, and he draws hundreds of them, different ways. Maybe one tilted on the left, one tilted on the right, and so on. But still, that they look like zeros. And then he does 100 ones, 100 twos, and so on. So at the end, he manually writes 1,000 images, 1,000 handwritten digits. So what he has done, he has created what's called in machine learning a data set. And also for each of these images, he assigns a label. So for example, he draws a 0 and he assigns a label to it. So he tells this is a 0. He draws a 1 and he assigns the label 1 to it. So there will be 1,000 images and each image will have a label attached to it. So this is the approach that he uses to solve this problem. Then he does something else. He decides to so he creates a data set. We just talked about it, and then he decides to split its data set in two. Actually, not in half, but 70% and 30%. So, so 70, he splits it randomly, right? So of the 1,000 pictures that he created, 700 is going to be one group, and 300 is going to be the other group. And he does this because he wants the algorithm, the computer to learn by itself. He doesn't want to teach him how to recognize it, but he just wants to give many examples to the computer so that he figures out by itself a way to identify each number. So what he's going to do is to feed the computer with the 700, the group of 700. This was the training set because it will train the algorithm. So it will give the 700 images and the 700 labels. So, and he tells it, well, figure out a way to recognize them. And then he will also give the 300 images, but the second group, but he will not give the labels of the 300 images because he wants to test it. So this is called the test set. He wants to test how good he got at recognizing these digits, how well, how good he is at telling them apart. So, yeah. So we can think of the model, which is the algorithm at the end when it's been trained, it becomes a model. We can think of it as an industrial machine. So on one side, we feed in some inputs, and on the other side, we get some outputs. So far, you can think of it as a machine. In our case, the input, which is when we want to recognize the digits, we just put a digital image. So a list of zeros and ones, as we saw earlier. And the output is going to be the corresponding label. So even if it's a picture that he has never seen before of a digit, he will be able to tell which number it is. And if we want to be more specific, we can call this machine a mathematical function. So imagine that, I don't know if you're familiar with this, but f of x is equal to y. So this is a mathematical function. And the x is the input and the y is the output. So another name for it is a mathematical function. And specifically, there are some gears inside that can be tweaked and adjusted. And these are the parameters. So initially, these parameters start randomly. So they could be any setting. But then over time, the algorithm has the goal of minimizing the error. So minimizing the number of wrong predictions. And it will by itself adjust its parameters to make sure that he guesses correctly most of the time. Any questions so far? Is it clear? All good? Are you sure? All right. Okay, so he tries this approach and he's happy because he finds out that his algorithm, his model, is able to predict accurately 90%, 98% of the times. So we said that he is testing with a test set of 300 images. Uh, so this means that 98% of the times it's correct. So if these 300 images, like it's a picture of a one, then the output will be a one. It means it's correct. If it puts a one by the output, an image of a one by the output is zero, then it's incorrect. So 98% accuracy, it means that out of the 300 pictures that he's using to test how good this model is, 254 are correct and 6 are wrong. So he's quite happy with it.